This video is brought to you by mywayteaching.com.
In this part, we are going to start a third unit of physics. The third unit of physics, as we all know, it's a very interesting topic, and that is the chapter name is motion in a straight line. So here we are going to discuss about motion, that too motion in a straight line. So what exactly we are going to study in this? Yes, the contents are as follows. First, we are going to study what is this motion, what is this motion in a straight line. So that will come in the introduction part, isn't it? Yeah. Then we are going to study about the position, path length, and displacement, and then average velocity and average speed. Even we are going to study about the instantaneous velocity and speed. So when velocity, speed, what about acceleration? Yes, we are going to study about this acceleration, the meaning of acceleration in the next part, and then kinematic equations for uniformly accelerated motion. And last but not the least, we are going to deal with relative velocity concepts. So, all these concepts are very easy, and this chapter itself is very interesting. So, now let us move to the first part of the chapter, that is the introductory part. Motion. What is this motion? We know this motion is common to everything in the universe, isn't it? For example, we walk, it is a form of motion, isn't it? And even we run and ride a bicycle. Even when we are sleeping, air moves into and out of the lungs, and blood flows in arteries and veins. We see leaves falling from trees and water flowing down a dam. Automobiles and planes carry people from one place to the other. The earth rotates once every 24 hours and revolves round the sun once in a year. So, this motion is everywhere in the universe. These are all the very simple examples. Okay. The sun itself is in motion in the Milky Way galaxy. So our galaxy is Milky Way, and the sun itself is in motion in that galaxy, which is again moving within its local group of galaxies. So from all these examples, one thing is clear, that motion is nothing but a change in position of an object with time. Okay, a change in position of an object with time. How does the position change with time? The question arises, isn't it? How does this position change with time? Yes, in this chapter we shall learn how to describe motion, and how this all this mechanism takes place. All those things we are going to study about in this chapter. For the case of this rectilinear motion, which means the motion of objects along a straight line, is called as rectilinear motion. Okay. Another name for this chapter we can say it is rectilinear motion. the motion of object along a straight line. So, for the case of this rectilinear motion with uniform acceleration, a set of simple equations can be obtained. So, we are going to study about all those equations in this chapter. Now, let us see what is this kinematics and what is this kinetics. Kinematics is a branch of physics dealing with motion without considering its causes. So, in studying the kinematics, will not worry why, okay, what is the reason behind that motion, okay. If any object is in motion, we say it is in motion. We'll not worry about the reason behind that. Background story we don't want. In the case of kinematics, what is this kinetics then? So it is exactly the reverse of it. So it is also a branch of physics describing motion along with its cause as well as properties. So in kinetics, if I say a object is in motion, first we should we should know how, what is the reason, what is the cause, okay. Behind that, and what are the properties of that kind of motion. So we are going to study each and every the part of that motion, okay, the things which are related to that motion and especially the causes. So in this chapter we are not dealing with this kinetics, we are dealing with kinematics, okay, a branch of physics which is dealing with motion without considering its causes. Moving to the next part, that is the concept of a particle. What is this particle? The concept of particle. A particle is a point like object endowed with mass. Okay, if we consider any point like object which is having some particular mass, then we can call it as a particle. So, in practice, it is very difficult to get such an object because an object would have some dimensions, isn't it? But in certain circumstances, an object can be treated as a particle. So, what are those circumstances? Let us study. The first circumstance is all the particles of a solid body performing linear motion cover the same distance in the same time, isn't it? A whole body is made up of n number of particles. So if I walk, all those particles will cover the same distance in the same time, isn't it? Hence, the motion of such a body can be described in terms of the motion of any of its constituent particles. So, we can describe the motion of whole body by considering any one particle of the body because all the particles move with the same, they cover the same distance in the same amount of time. So, we can consider the entire body as a, it is just like a particle, isn't it? So that is one circumstance where we can see this concept of particles, okay, in case of solid body. And in the second case, if the distance between two objects is very large as compared to their dimensions, those objects can be treated as particles, okay, if the distance between two objects is very large. So those objects can be treated as particles. For example, while calculating the gravitational force between the sun and the earth, both of them can be considered as particles. Okay, if I want to calculate the gravitational force of the sun as well as the earth, okay, then we can consider these two as the particles because the distance between them is very the distance between them is very, yeah, large compared to their masses. Okay, compared to their sizes the distance is very large. In that case we can consider these objects as particle. This is the concept of particle and the two circumstances where we can consider objects as particles. Now let us see what is this frame of reference, isn't it? How can we know that the object is at rest or in motion? In order to answer this question, we should consider a very simple example. You just imagine in your mind. Suppose a bag is lying in a train moving with a constant speed. A passenger in the train would find the bag stationary, but a person standing by the roadside would find the bag in motion. Okay, if the bag is in the train, the passenger who is traveling with the same speed as that of the train, for him that bag is at rest, isn't it? But for the man who is standing outside the train, that bag is in motion, isn't it? Thus, the bag is at rest if it is absorbed from the train, and it is in motion if it is absorbed from the roadside. If we absorb the trees, building from then, okay, if you observe all those things, they are stationary, but from the train they will be found to be in motion. So if we observe those trees, building standing outside the train, then it will be stationary for you. And if you are in a train, then all those things will be in motion. Thus, motion is a combined property of the object under study and the observer. So, how can we define this frame of reference then? Yes, a frame of reference is a place and a situation from where observer takes his observation. So it depends on the place where he is, whether he is standing inside the train or outside the train in the example that I gave you just now. So that entire observation depends on that frame, isn't it? Exactly where the objects are. So in the above illustration, means in the above example that I gave you, or that is of the bag, the frame of reference for the passenger is the train moving with constant speed, isn't it? For passenger, the frame of reference will be train, isn't it? Moving with constant speed. While for the observer standing by the roadside, the frame of reference is the stationary earth. Okay. Okay. So depending on this position, the frame of reference, the position in that frame of reference, we can the motion differs whether he is in motion or whether the object is in rest. That depends on the position of this object, okay, where exactly it is.